All right, so now that we know how glaciers move, relatively speaking, what is the absolute movement and speed of these things? Well, just as you'd expect, it varies widely. Um, Very similar to how we have drag and friction that acts on the water flowing down a river from the edges and floor of riverbanks. Same thing is true of glaciers, and except more so because we have ice, of course, that's a solid flowing next to another solid rather than a very weak, shearless water, fluid material flowing down a river. So ice moves, of course, much slower, but it moves at different velocities within the glacier. This is a pretty cool diagram that shows some measurements of how glacial speed was measured in the late 1800s. And what was done by scientists is they placed a row of stakes in a straight line across a glacier from one bank to another. They came back in successive years and saw that the middle of the glacier is moving much faster than the edges of the glacier, and assumed that the bottom of the glacier is moving slower than the middle as well. And that makes sense due to decreased friction from the edges. Additionally, they saw that the terminus, the end of the glacier, was retreating. So even though you have the top of the glacier moving forward, you still have the bottom of the glacier moving back. So in this case, we are losing ice somewhere, and for some reason, we see it creeping back up the mountain.